All right. 3 things I want to go right off the bat with you before we start any word problems or answer any questions. 3 things with probability. Can never be negative. Okay, that's what I have down here. Probabilities can never be negative. What's the chances, I get a 3 on a die? It's never negative 2/5. All right, chances are never negative. If you're going to tell me the probability is equal to 1, that means it's going to happen. All right, it is going to happen. Anybody think they could come up with an example that would have a probability of 1? It will happen. Nothing? It's fine. Probability you roll a number 1 through 6 on a die. Probability you roll the numbers 1, 2, 3, 4, 5, or 6 on a die. It's got to happen. Everyone agree? I got a standard die. It's got to show up 1, 2, 3, 4, 5, or 6. All right, that's 100% chance. If you're going to tell me the probability is 0, that means it's impossible. It can never happen. Probability I roll a 7. It's not going to happen, right? And I just have 1. 1 die, it's not going to happen. Everyone, you're good. Maybe I should have picked different examples. All right. All probabilities got to becomes between 0 and 1, and they're never negative. We all good? So 2/3, 1/6, all these different types of fractions. There are 2 types of probabilities I want you to be aware of. First one I'll just speak on. Theoretical. Theoretical. What's the probability I roll a 2 on a die? 1 out of 6. You guys know your cards at all or no? What's the probability I pick a 2 out? You know how many 2s are in the deck? 4 2s out of 52. So there's a 4 out of 52 chance. All right. That's called theoretical probability, meaning it should happen. This is the probability that it should happen. Experimental. Let me explain about this one. So just focus up real quick. Experimental. So here's my dice rolling simulation. All right. I'm going to roll the die 100 times and record every time that comes up. Ready? Okay. That's what came up. Based on my experiment here, my simulation, on my next roll, what do you think is most likely to come out? 6. Probably 6. That's what you would agree on. That's called experimental probability because they all have the same chance to come up next, correct? Everyone, right? The next roll I have, my 101 roll, I could get a 1, 2, 3, 4, 5, 6 equally. All right? But you guys would predict that I'd probably get a 6. That's experimental probability. Probability based on an experiment or a simulation. All right? Everyone see the difference there? No, we'll be rolling die tomorrow. So everybody all good? Okay, so theoretical is what should happen. All right, 1/6, the 4 out of 52, picking a 2 out of the deck of cards. Experimental is based on an experiment I did, here are the chances coming up. We all good? All right, because you're going to answer a couple questions on whether it's experimental or theoretical, so I know you have this down. So you got the weatherman. He predicts a 40% chance of rain for today. What type of probability represents that 40%? Experimental or theoretical? Now think about where he got that from. I know you probably need to know some stuff about the weather, but where do they get their chances from? Okay, science, simulations, different weather models, yes? So this is what type, where do you get that 40% from? From doing? Experimental, yes. Okay, and then there's a chance a fair coin lands heads is 1/2. You guys knew that? What type of probability is the 1/2? Theoretical, it should be 1/2. So everyone all right? It's experimental is you base your probability off of an experiment or simulation that you did. All right, I just want to make sure we're good here before I get any more complicated. 6-sided die. What's the probability I roll a 1 or a 5? Well, how many? 2. Where's the 2 come from? Just explain to me where the 2 comes from. 2 choices, 1 or a 5. And then where'd the 6 come from? 6 different chances. Okay? Are we all good there? You don't have to explain that anymore. And then if you want, I'm not requiring it, but you can reduce it down to 1/3 if you want. What about probability? I roll an even number now. How many evens are on the die? 2, 4, 6. There's 3, right? And at any time during this unit, you don't know like the different number of like I don't expect you to know cards because for some reason you guys don't play cards anymore. It's a shame, but just let me know. All right, I don't know if you guys have been exposed to a die before. I'm not assuming that. And then again, 3 out of 6. It seems silly, but you'd be surprised. Questions there? Okay, next up. So you got a half-hour program, 8 minutes used for commercials. So at any random time, I'm going to turn this TV on. What's the probability that a commercial is not being shown? Not being shown. So something in between 0 and 1. What are my total number of minutes here, guys? 30 minutes, right? 30-minute show. Out of those 30 minutes, what's the probability? How many minutes not being shown a commercial here? A commercial is not being shown. Nick, what do you got? Why 22? I got 4 commercials, so the rest of the time should be 22 minutes. Yep, and again, if you want to reduce that, you can. Questions on you guys? All right, so there you go, the cafeteria before school one morning. We got different types of juices. Marcel's going in. He's just going to grab a juice at random. What's the probability he or she, I'm not too sure, gets orange or grapefruit? Orange or grapefruit. So put the 2 together. How many choices are there? 20. Orange or grapefruit. How many total choices do you have? 18 orange, 7 grapefruit. Total? Oh boy. Oh boy. Orange or grapefruit. I look at the chart. There's 18 orange, 7 grapefruit for a total of 25 out of how many total? 40 if I add them all up. That answer is not there because I simplified all my choices. You know you can go to the calculator and 25 over 40 and it'll reduce it for you. 5 over 8. Are we okay right now? All right, here we go. Oh, I don't know if anybody's done this yet, though. I'm going to flip a coin 3 times. Write down the result. Have you guys ever heard of sample space before? No? Okay, good. What we're going to do first is organize every single outcome using a, have you heard of this before? Or maybe drawn one yourself back in the day, tree diagram. Looks like, this. Seen that bad boy before or no? Okay, good. All right, so here we go. For part A, we're going to do a tree diagram. How many times am I flipping the coin? 3. Ready? Flip 1. What are my choices? Just like that. What are my choices? Heads or tails? So the first one on the tree diagram, it could come up a head or a tail. That's first flip number one. Those are my choices. Everyone agrees. All right, ready? Flip number two. Done. If it came up ahead the first time, watch my language here. If it came up ahead the first time, what are the options for the second flip? Still heads or. So off of the head here, we're going to go heads or tails. Well, what if it came up a tail first? What are my options for the second flip? Still the same thing. Head or tails. So there's the first flip, second flip, third. Done. What if I had two heads to begin with? What are my choices for the third one? So what's going to come off this H? H or a tail? Well, what if I went heads, tails the first two? It's not going to change anything. Everybody good? Now, if you count the bottom row, that'll tell you how many different outcomes there are. Okay, so if you count the bottom row, how many different outcomes do I have? 8 different ways it could come up heads and tails. That's one way of showing your outcomes. It's called a tree diagram. The other is called listing it out as a sample space, which is literally just writing down all the possible outcomes you could think of. So you can use the tree diagram to cheat here. Give me one order of ways it could come out. Here we go. We're going to go, since there's 8 of them, I should hear 8 different responses here. All right, here we go. Let's start off this game with number 10. Give me one way it could come out. All heads. So H, comma, H, comma, H. I'm listing these all out now. This is called the sample space. Tree diagram to the left, sample space to the right. Give me another way here. We're rolling. Oh, 13. All tails. Got it. Again, if you need help, use the tree diagram. We listed them out already. Here you go. 11. What else could I have? Heads, tails, heads. Got it. 3 down, 5 to go. 12. What else you got for me? Thanks. Halfway home, everybody. Halfway home. Missing 4 more. 11. Up. Got that one. Heads, tail. Don't have that one. 3 more to go. 9. I already have that one. Once again, I have that one.
Tails, heads, tails.
13, another one. Again, guys, go. What is it? And looks like I have one more. Oh boy. If anybody gives me heads, heads, tails, we're good. 2. All right. So hopefully we just proved to ourselves tree diagram, if you can draw one's the way to go. Okay, because you may think you have all of them, but you maybe have forgotten one. Tree diagram, it doesn't allow you to do that. All right, use either one, I don't care. What's the probability I get all heads here? Probability I get all heads. How many choices are all, first, how many choices are all heads? 8, how many choices are all heads? We have an 8. How many all heads, Lily? 1 out of how many choices did we say? 8. 1/8. Got it. Okay, count if you need to. Exactly 2 heads now. Exactly 2 heads. Not less, not more. Exactly 2 heads. You can just give me the full probabilities now. 5. 2 over 8. If you want to reduce it to 1/4, I'm fine. Yep, it would. We're missing one, Alex. Right? We had that one, and that one. So what do you got? 3 over 8. All heads or all tails. Either one. 13. 2 over 8. Done. We feel all right here. Going. Hey, let's go to the school carnival. A little ring toss. Anybody? Ring toss? Okay, good talk. You got a prize bag that contains, ooh, how about this? 2 sunglasses, 3 necklaces, and a keychain. Lucky, lucky winners. John's the first one to win. Find the probability he chooses the keychain. Yeah, look at that. Yeah. What's the probability we get the keychain? 14. How many keychains are in the bag?
1.
Out of how many prizes?
6.
Yep. Well, I decided to pick the sunglasses instead. So whoever wins second, what's the probability they'll pick the keychain now? Because it is not 1/6. Let's see if anybody picks up on that. So I picked the sunglasses. 15. How many keychains are still in the bag? 1, but how many prizes? 5. Everyone see that? Because the sunglasses left, there's not 6, there's 5 now. All good there? Okay, because this last one, I think it's the last one with the multiple choice. Yep. Okay, this one could get a little confusing here. You're taking a quiz. You randomly guess the answers to 2 multiple choice questions, but they have what? 3 choices. So just so you guys can visually see what we're working with right now. I got question 1, question 2, and there are 3 choices for each. Okay, everyone good? One of them's right. The other 2 are what? Wrong. Okay, one of the choices are right. The other 2 is wrong. All right, so let's see if we can do the tree diagram here. Okay, we go to question 1. How many times can you get it right? How many times could you get it wrong? How many times could you get it right? Okay, so I'm going to put an R for right. You could get it right or wrong, but you're going to get it wrong. You have 2 options to get it wrong. So I'm going to put not just 1, but 2 W's for wrong. Does everyone see that? It's just not R and W. That means you have a 50-50 shot. Does everyone see where the R and Y 2 W's are up there now? We're all good. That's question 1. Question 2. Let's say you got the first question right. What are your options for question 2? Still what? 1 right answer and 2 wrong. So off the R, I'm going to put how many branches? Yep. Right, wrong, wrong. Okay, what if you got you chose one of the wrong responses in question 1? You could go what? It's still the same options. Pick the right one or one of the 2 wrong ones. And the same thing is going to come off of the final W. What is that? Now I know some of you are, well, isn't that the same? You know, right, or wrong, right, and wrong, right? No, it's not. Because you could have, let's say right now, ready? Let's say choice A is the right answer on number 2. What this is saying is you could have, I'll put here, both of them are choice A. What this one is saying here is you picked, let's say, B and then A, versus this one, you pick C, then A. There's 2 different options there. See that one? Okay, because some of you may be looking at this and being like, well, they're the exact same. No, no, no. You picked a different wrong answer. Okay? All right, what's the probability you guess correctly on both questions? Probability you guess correctly on both the questions. 5. How many times could you guess correctly on both? On both. Once, RR. That's what that, once out of how many different combinations do you have? Remember, count the last line. That'll always tell you. You have 1 out of 9 chance. How about that? If you just guess. On this, that's only 2 questions. You got a 1 out of 9 chance of getting it both right. What's the probability you guessed correctly on only one of the questions? On only one question, you guessed right. Okay, 16? Who's got? Okay, so what I want to do here, Rachel, is I want to go through each one and see if it counts. All right, so your classmates know where this final number is coming from. Does RR count? No. RW? RW. Okay, so I got 2 right there. WR? WW? WW? Nope. Go to the third pair. WR? WW? WW. So how many did I have? 4 out of 9. So you have a 4 out of 9 shot of getting only one correctly. All right, questions? Got your Chromebooks on you. Let's get them out. Open up my answer key from this week, and let's get going. You should be able to finish. I'll come around and help you out if you need it. Make sure on Aspen you open up Unit 5, probability.